Hello, geometry class. In this video, I'm going to go over the notes for Chapter 7, Section 4, Special Right Triangles. As you know, with a right triangle, and as we've been going through in Chapter 7, a right triangle is unique in that when you have a right triangle where one of the angles is 90 degrees, you may use the Pythagorean theorem, and the Pythagorean theorem allows you to find the third side of a triangle when you're given the other two sides. So if you're given two sides in a right triangle, you can use the Pythagorean theorem to find the third side. Depending on which two sides you're given, it depends on how you do it. For instance, again, right triangle, this is a right triangle. This is an example of a right triangle here. The two sides that are connected to the right angle, this is the right angle, this red box that I'm circling with my cursor. This is a leg, this is a leg, this is the hypotenuse. The two legs are attached to the right angle. The hypotenuse is opposite the right angle. So, depending on what you were given with a right triangle, if you were given both legs, or if you're given a leg or a hypotenuse, you still use the Pythagorean theorem. It's just if you were given both legs, you would add the two numbers. And the Pythagorean theorem again is leg squared plus leg squared equals hypotenuse squared. You would with the legs, you would add them together. With the hypotenuse and one of the legs, you would subtract. You'd still be able to find the third side. Okay, so that's just a little bit of a recap of what Pythagorean theorem does. Now, what makes us there's a couple of triangles that are special. What makes them unique is, unlike the other right triangles that require two sides, and then you can find the third, there are two cases, and this is one of them that I'm showing here on the screen right now. But there are two cases of right triangles where you don't even have to be given two. You only need to be given one side, and from that one side, you can find the other two side lengths. So instead of being given two sides and being able to find one, we can be given one side and you're able, using that one side, to find the other two sides. So that's what makes special right triangles unique, and there's two types of them. The first type of special right triangle we're going to look at is the 45-45-90 right triangle. I'm sorry, 45-45-90 triangle. 45-45 right triangle. 90 and right are redundant when I say them at the same time. 45-45-90 right triangle is a little redundant. That's why I corrected myself. And what makes this unique is, if you remember, the other thing that we covered in the past was that the angle and the side opposite have a special connection, in that the smallest angle is opposite the shortest side, and the longest angle is opposite the longest side, or the largest angle, I should say. And then the middle angle, whichever angle's between those two, would be opposite the side length that's between the two other side lengths. Well, in this case, we have a 45-45-90 right triangle. We have two angles that are equal. They're both 45. Well, what that means is the sides opposite each of those angles will be equal. So, whatever one of the legs is, the other leg is that same length. But not only that, we also have a relationship that leg length has with the hypotenuse. And if we were given one leg, we would know what the other leg is because it's equal to it. We could use Pythagorean theorem, but there's a faster way to do it, and that is to multiply whatever that leg length is by the square root of 2. Well, let's talk about the square root of 2. The square root of 2 is a number just like any other number. So if you had x times 4, that would be taking x times the number 4, which is a nicer number. Square root of 2 is treated just like 4, just like 7, just like any other number, 1/2. The reason we write it as square root of 2 is, though, it's irrational. It's kind of like, it is like pi in that it's irrational. So let me boot up my calculator and clear it here. I'm going to put square root of 2. I know you don't have a graphing calculator. You can do this on any calculator. Do square root of 2, you put that in, and it's 1.414, and it just goes on. And even the calculator cuts this off at some point. It'll go on forever. Irrational, does not repeat, does not end. Square root of 2 is a number. So the unique thing about a 45, 45, 90, 45, 45, 90 triangle is that the leg times the square root of 2, that irrational number, will be the length of the hypotenuse. Hopefully that makes sense. Going back to this number, the reason we write square root of 2 is because it's more exact. If we would put 1.414, we would be rounding it, that number, the square root of 2, and it would be better to round it. It's often okay to round a number, but it's better to round it at the end of the problem if you can, not at the beginning. So we're going to leave that as square root of 2. Just remember, that is just like any other number. So you can divide both sides by it. You can subtract by it. We won't need to do that, but it's possible to do that. Square root of 2 is a number. Okay, so let's look at example 1 here. Not show too much work right off the bat. Okay, so example 1. Find the length of the hypotenuse. We're given this right triangle. You can see it's a right triangle because of the red square. That's the 90-degree angle. This is 45. Remember that every triangle adds up, all three angles add up to 180, 90, 45. That would leave 45 for this side, which means this is a 45, 45, 90 triangle. So that means, and they also give us 8 for this leg. That means this other leg is 8, but they don't ask us for that leg. They want us to find the hypotenuse. We can use hypotenuse equals leg times root 2. We're going to plug in 8 for the length of the leg, and we're going to be looking for the length of the hypotenuse. Okay, 8 root 2. And that'll actually be our answer for some of the problems. They say leave, this problem doesn't say it, but some problems that you do in the book and on work packets will say leave problem in simplest radical form, 8 root 2. Well, 8 root 2, and some problems it might make more sense. That's the wrong calculator. Some problems it might make more sense to put it in decimal form. But let me just show you here. 8 times square root of 2, enter, is the 11.313. Again, you don't have a graphing calculator, but your scientific calculator should be able to do what I just did. Okay. So that's example 1, part A. Let's do another example. Again, we have a right triangle. Now, they don't give us any angle measures, but they do tell us both legs are equal, which means, well, they tell us both legs are 3 root 2, which means opposite angles are equal. Okay, the angle here is equal to the angle here. Well, this is 90 here. That leaves 90 to be split between these two angles. And 90 divided by 2 is 45. So that means this is a 45, 45, 90 right triangle, 45, 45, 90 triangle. Hypotenuse equals leg times root 2 is the formula we are going to use. Our leg length is 3 root 2. So we have 3 root 2 times root 2. Well, let me just show you something here. If I'm given the square root of 2, and I multiply that by the square root of 2, what do you think that's going to be? Well, it's going to be 2. It's going to be exactly 2. And that is because a root 2 times root 2 is the same as root 2 squared. Just like 4 times 4 is 4 squared. Well, the square root and the squared are opposite of each other. The square root cancels out a squared, and a squared cancels out a square root. So the square root of 2 times the square root of 2 is actually just 2. And I'm just going to change these two things to 2. And I'm going to show the times between the 3 and the root 2 here. That wasn't shown because of the radical. So 3 times 2 is 6. Okay, see how that worked out. Now, just so you know, I mean, if you didn't do that, that's fine. If you would have went through the process of 3 times root 2, I found what that is. That's that long decimal. I'm going to take that answer, and I'm going to multiply that by root 2. you'll see that your graphing calculator, as long as you use this answer feature on your, sorry, not your graphing calculator, but whichever calculator, scientific calculators do this as well. As long as you use this answer feature, and don't round it at all, and use this answer feature that I actually have been emphasizing a lot recently, you will get 6 anyway on your graphing calculator, even if you did this first and then multiplied that by root 2. Either way, you're going to get the exact value of 6. Speaking of exact, I don't think I pointed this out. Going back up to part A here, which is still shown at the top of the screen here, when I did round, when I got 11.314 and then I stopped writing all those decimals, I do use the approximately equal to symbol. Down here I don't have to use that because 6 does not go on forever. It doesn't even have a decimal. Okay, so I have approximately equal to. Whenever I round, I need to use approximately equal to. Okay, but down here I was able to avoid that by doing the root 2 times root 2 first. Getting that to just 2, I was able to avoid the approximately equal to, and that's why I did that. If I would have done 3 root 2 first, and then I had a long decimal, I would write that decimal down, but then I'd have to switch to approximately equal to that decimal times root 2, and then it would actually go back to 6 if you do it right. Go back to an exact if you do it right. Hopefully that makes sense. All right, here's example 2. Find the lengths of the legs in the triangle below. So in this case, we have a right triangle. We're told that these two legs are equal, just like part B of example 1. If these two legs are equal, then opposite angles are equal. That means this is a 45, 45, 90 triangle. In this case, though, unlike the other 2 examples we did, we are given the hypotenuse and we're asked to find the leg. So this is taking the same equation we've been using, except we're flipping it, or not flipping, but we're reversing it, and we're going to put the 5 root 2 in for the hypotenuse, and we're going to solve for the legs. I'm going to put an x in for the leg. They actually give us the x, so that's why I have to put the x in. Now we're going to solve this just like any other equation that you would want to solve for, and that would be, and remember, root 2 is just a number. So I can, if I have a times a number, x times a number, I can divide both sides by that number. So I'm going to divide both sides by root 2. A root 2 divided by a root 2 will cancel out, and that's why we do that. It'll cancel out on the x, it'll cancel out over here, and we'll be left with just 5 equals x, or x equals 5. So the answer to example 2 is 5. All right, so that was the 45, 45, 90 triangle. The other special triangle, special right triangle, is the 30, 60, 90 triangle. So again, what makes this unique is that I only need to be given one side and I can find the other 2 sides instead of being given 2 sides and able to find one. But it has to be a 30, 60, 90, or it has to be a 45, 45, 90 triangle. So this one's a little more complicated because unlike the 45, 45, 90 triangle where 2 sides are equal, there's no 2 sides that are equal in a 30, 60, 90 triangle. All 3 sides have different lengths, but they still share a common proportion amongst themselves. And what that is the shorter side, the side that's shortest. So here we're looking at this triangle right here, 30, 60, 90. The side that's shortest, which will be the side opposite the 30 degrees, this 30 degrees here, this would be the shortest side, will always be half the hypotenuse. That's the longest side, the side opposite the right angle. So the shortest side will always be half the hypotenuse, or the longest, or the hypotenuse, I should say, which is the longest side. The hypotenuse is always double the shortest side. Okay, so hypotenuse will equal 2 times the shorter leg. Now, there's also a ratio or a relationship between the longer leg, not the longest side, but the longest leg. Of the 2 legs, the one that's longer will be the shorter leg times root 3. Again, root 3 is just a number. It's a decimal, irrational number, 1.7 3, 2, but we like to put it as root 3 and leave it as root 3 because that's more exact. So these are two formulas that we will need to use for the 30, 60, 90 right triangle. Sorry, 30, 60, 90 triangle. And depending on what we're given, we might be given the shorter leg, and then we would be able to find the hypotenuse in the longer leg just using that shorter leg. That would be probably the easiest and the most ideal, but that's not always going to be the case. If we were given the hypotenuse, we'd use this first formula in reverse, divide both sides by 2 to find the shorter leg, and then use the shorter leg to find the longer leg. If we were given the longer leg, we would use the bottom formula here, plug in for longer leg, divide both sides by root 3 to find the shorter leg, and then plug that in to find the hypotenuse. So either way, no matter what we're given, what side we're given, we can find the other two sides, but they all go through shorter legs. So you have to find the shorter leg. If you're not given the shorter leg, you have to find the shorter leg, and then use that to find the other one, whichever one they didn't give you. Hopefully that's making sense. And I don't know why that jumped. Example 3. Ready for example 3? All right, so 30, 60, 90. There we have it, 30, 60, and 90. And they give us this 9 down here, and they ask us for x and y. So x is across from the 30. That makes x the shortest leg, or the shorter leg. Okay. 9 is across the 60. That makes 9 the longer leg. We're going to want to find the shorter leg first, using the fact that we know what the longer leg is. So we're using the longer leg equals shorter leg times root 3. I'm plugging in 9 for the longer leg, x for the shorter leg, because they gave us a value for that, and I'm going to solve this for x. So that is done by dividing both sides by root 3, just like an example above that we did. Root 3 is just a number, like root 2, like 4, so we can divide both sides by it. And we have 9 root 3, and then over here the root 3's cancel out. That was the point. But the problem with 9 root 3 is there's something else going on here. We could convert this to a decimal value, but then it wouldn't be exact. And depending on the problem, and in this particular problem it says write your answer in simplest radical form. Well, that tells us we can't round. They don't want us to round the answer. They want it to be exact, which means leave radicals in there. But the other thing going on is that mathematics in general, we don't leave radicals in denominators. That's not a good thing. So I'm going to rewrite this fraction and essentially get rid of the radical in the denominator while not changing the value. And the way I do that is I multiply both the top and the bottom by whatever's in the denominator. So just to rewind for a second here, if I have the fraction 1/2, for instance, just 1 over 2, I can multiply 1/2 by any number in the top and the bottom. As long as it's the same number in the top and the same number in the bottom, I can multiply 1/2 by 2 times on the top and 2 in the bottom and get 2/4. We all know that 2/4 is the same thing as 1/2. They're both 0.5. Well, that's the exact same thing that I'm doing here. I'm multiplying the top by root 3, the bottom by root 3. It does not change the fraction. It just changes the appearance of the fraction. So what happens on the top is I have 9 root 3, because multiplying those together won't give me a decimal. But what happens in the bottom is what's important. And that is what's happening on the bottom is the same thing that happens, what I said earlier with the root 2 times root 2. Well, root 2 times root 2 went to 2. Well, root 3 times root 3 is going to do the same thing. Root 3 times root 3 is going to go to 3. And that's the whole purpose of this, was to get rid of the radical in the denominator. Not get rid of the number in the denominator necessarily, just the radical. So that 9 root 3 over 3 is what we get. And then from that, 9 and 3 will simplify to just 3. So I have 3 root 3. And this is considered the simplest radical form. So just to go back, if I did 9 divided by root 3 in the calculator, because let's say this problem allowed decimals, and you could just write that down in a different scenario, 5.196. That decimal value will be equivalent to the simplest radical form that we just found of that value. And you see how these decimals match? That means this is equal to this. It's just that this is simplest radical form. This is not. Okay? So I just wanted to confirm that on the calculator by putting both the value we got, the answer we got, and the unsimplified and the simplified radical form. Gives you the same decimal. So we didn't do anything wrong there. As far as changing that value, it did not change. Hopefully that makes sense. Okay, so once we've found x, which we did, this is 3 root 3, we can then use that to find y. Remember, shorter leg times 2, or 2 times shorter leg, is equal to the hypotenuse. Well, now we have the shorter leg. That is 3 root 3. We're going to take 2 times 3 times root 3, and 2 times 3 is 6, and we are actually done because we want the simplest radical form. But I did put the decimal values here just in case you're curious what they looked like. I showed you that one a minute ago. 6 root 3. There's that decimal value. Because I have the simplest radical form, that I answered the problem. The problem, what it wanted was the simplest radical forms, and they are there. All right. Another example. The body of a dump truck. Okay, there's a picture to go along with this. Sorry. Okay. The body of a dump truck is raised to empty a load of sand. How high is the 14-foot body from the frame when it is tipped upward at the given angle? And in this image, it's tipped upward at a 45-degree angle. And you can see here that 14 is the hypotenuse. It's opposite the right angle. Okay, so we want to use the hypotenuse equals leg times root 2 formula. The leg we're interested in is this leg that's a height. That's why I used h, but it would actually be the same measure as the base here, because in a 45-45-90 triangle, the legs are equal. So 14 is equal to the height times root 2. We're going to divide both sides by root 2. 14 root 2, which I'm going to give you both the simplest radical form and the decimal form. Again, 14 over root 2 is not simplest radical form. Multiply both the top and the bottom by root 2 over root 2. That's 14 root 2 over 2. The radical cancels out in the denominator. And we have 14 divided by 2, which goes to 7. On your calculator, 7 root 2 is equal to 9.899 feet, which 9.9 feet would suffice. Okay, let me just quickly double check that I didn't make a mistake in simplifying the radical. I'm going to go back to 14 over root 2 is what we found, and that is the same decimal. So I did the simplest radical form. They didn't ask for it, but I just wanted you to see that done again. Because some problems will ask for it. This is a word problem. It's probably not going to be useful to say, oh, it's 7 root 2 to the truck driver, whoever wants to know. They're going to want 9.9. But remember, this is exact. If I have an exact value for something, I can round it any time I need to. And then if I have a rounded number and I give that out, then people don't know where it came from. They can't round it. That's why exact is so nice. An exact number you can just take and round whenever you need to. Rounded numbers given out, you don't know what it was rounded from. Hopefully that makes sense. 30, 60, 90 triangle, so this is part B of the same dump truck. It's now up higher. We have a 30, 60, 90. It's still 14 feet. The bed didn't change. But you can see it's much higher. Well, maybe I shouldn't say much. It is higher. The base is smaller, but it's a 30, 60, 90 triangle because if this angle is 60, this is 90. That out of the 180 that all three angles add up to, that leaves 30 up here. And we want to know the height. The base, we don't know. 14 is the hypotenuse. But in order to find the shorter leg, I'm sorry, in order to find the height, we need to find the shorter leg. We have to go, everything has to go through the shorter leg for the 30, 60, 90 triangle. We know that hypotenuse is equal to 2 times shorter leg, so 14 is equal to 2, and I'm going to use S for shorter leg, dividing both sides by 2, and it makes sense that the shorter leg is 7, because remember the hypotenuse and shorter leg, the shorter leg is always half the hypotenuse, or the hypotenuse is always double the shorter leg. Once I have the shorter leg, I can find the longer leg, which is the height we're looking for. So the hypotenuse, sorry, the height, the longer leg is equal to the shorter leg times root 3. The longer leg is equal to the shorter leg times root 3. So I'm using h for longer leg because I'm using h for height. The height of this triangle is equal to shorter leg times root 3. I can plug 7 in for shorter leg, and that is approximately 12.124. All right, so that wraps up the notes for section 4 of chapter 7, special right triangles. There's some bookwork here, and I do have screenshots of the bookwork. You don't have to pause this video. I'll put these screenshots up online somewhere for you to look at. So you don't have to just try and pause the video to watch and then do the problems. You can look online wherever I post them. Google Classroom obviously will be somewhere in there. So yeah, that wraps up this lesson, special right triangles, 45, 45, 90, 30, 60, 90. There are 3 formulas, the 2 for 30, 60, 90, the 1 for 45, 45, 90, and several examples. Thank you and good day.